Welcome, everyone. Today we are addressing one of the most critical yet misunderstood questions in the industrial sector. Who actually owns asset reliability? This isn't just a technical discussion about wrenches and sensors. It's a board-level conversation about accountability, risk, and how we protect enterprise value. My name is Santosh Raikar, and today I want to show you why reliability isn't a department. It's a leadership system. Let's start with the hard question that should be asked in every boardroom. When an asset fails, do we truly understand who owned that outcome? Too often, organizations say reliability is everyone's responsibility. While that sounds noble, it often means it becomes nobody's decision system. As leaders, our challenge is to define authority and risk before the next major failure forces our hand. The thesis for this session is simple. Operations, maintenance, and engineering all have vital, distinct roles. But no single function can deliver reliability alone. Leadership's primary job is to own the governance system that forces these functions to work together through shared outcomes, clear decision rights, and a disciplined operating rhythm. Our agenda today will take us from the high-level why of governance down to the practical how of implementation. We will explore the ownership paradox, the mechanics of risk acceptance, the data foundations required, and finally, a roadmap to help you build a more mature reliability culture. In Part 1, we'll examine why governance matters. We must shift our perspective to see reliability as a business outcome, not a maintenance function. Why should executives care? Because poor reliability is a value destroyer. It shows up as downtime, safety exposure, and customer disruption. Without governance, technical risks remain invisible until they explode into a crisis. The board doesn't need to manage work orders, but they do need assurance that asset risk and value are being actively governed. Reliability is an enterprise capability. Think of it as a product of your management system. It requires alignment between how we operate, how we maintain, and how we engineer. Governance is the framework that defines how this entire system decides, learns, and manages risk. Every function across the enterprise influences reliability, though they do so through different mechanisms. The goal of governance isn't to make everyone equal, but to make their specific accountabilities explicit. Leadership is the glue that connects these different pieces of the puzzle. What happens when governance is absent? We see critical work deferred without anyone signing off on the risk. We see repeat failures where everyone points fingers, but no one owns the permanent fix. In these environments, capital is often wasted on treating symptoms because the system isn't designed to remove the root causes. To be clear, governance is not just more meetings. In fact, a good model reduces them because it clarifies who makes which decision at the right level. The true test of your governance is simple. Can your organization make a clean run, stop, or redesign decision when a significant asset risk is identified? In Part 2, we tackle the ownership paradox and look at the specific roles each department plays in the reliability ecosystem. One of the most dangerous phrases in industry is maintenance owns reliability. While maintenance controls work quality and strategy, they don't control how equipment is operated or whether leadership chooses to bypass a repair. Assigning reliability to maintenance alone creates accountability without the necessary authority to succeed. Operations owns discipline operation. This means running equipment within its design limits and responding to abnormal conditions before they become failures. Operating discipline is a core reliability control. It shouldn't be viewed as a separate production issue. Maintenance, meanwhile, owns the care and quality of the work. Their job is to protect the asset from both natural degradation and maintenance-induced failures. Success isn't just a completed work order. It's a verified restoration of the asset's function. Engineering's role is to own capability and the permanent removal of defects. If engineering only shows up after something is broken for the third time, the organization is trapped in a reactive cycle. Governance should make design correction an expected path, not a rare exception. Ultimately, plant leadership owns the system. They're the ones who must resolve trade-offs between production urgency and asset health. This is where the buck stops. Leaders should never delegate the governance of reliability while still holding onto the authority for costs and production. Here we see an illustrative governance structure. It starts with the board setting risk appetite, flows through executives setting standards, and relies on reliability councils to integrate decisions across functional boundaries. Think of it as an equation. Authority without consequence leads to inconsistency, and accountability without authority leads to frustration. Governance solves this by connecting accountable owners with clear decision rights and transparent evidence. Part 3 is about the who and the how, clarifying decision rights and risk acceptance before a failure forces a crisis decision upon us. Decision rights are the heartbeat of governance. We need to know up front who can stop a machine to protect it, who accepts the risk when we defer a critical repair, who can break a frozen schedule. These shouldn't be questions we ask in the heat of the moment. They should be predefined. A RACI matrix isn't just more bureaucracy. It's a tool to prevent vague ownership. It ensures that accountability sits where the authority actually exists and dictates when a decision needs to be escalated to a higher level of leadership. Risk acceptance is a leadership act. When we defer a defect, we aren't just saving money, we are accepting risk. That acceptance should always include an owner, an expiration date, and specific operating controls. Silent deferral is a major governance failure that we must eliminate. Naturally, the more significant the consequence, the higher the decision should go. Escalation isn't about blame. It's about matching the level of authority to the level of financial or safety exposure involved. We also need to govern temporary repairs. Without visibility, temporary often becomes permanent until it fails again. Executives need to know the total population of high-risk temporary fixes currently in the plant. Maintenance backlog is more than just a list of work. It's a portfolio of deferred risk. Governance should allow us to look at our backlog and distinguish between routine work and high-consequence latent risks that could shut us down. For recurring losses, we need a clear escalation path. Detecting a loss is one thing, but verifying its permanent removal is another. Closing a work order doesn't mean the problem is gone. Governance ensures we close the actual loss. In Part 4, we look at the operating rhythm, the heartbeat of how governance becomes a repeatable habit across the organization. A healthy rhythm happens at 4 levels: daily reviews for immediate risks, weekly schedule locks for execution, monthly councils for repeat bad actors, and quarterly reviews for enterprise-level strategy and capital alignment. The daily review is about the last 24 hours. We classify issues without blame. Was it operating, engineering, or maintenance? And assign a clear owner and containment action immediately. The weekly schedule lock is where we protect our work quality. By freezing the plan, we ensure resources and parts are ready. We treat schedule break-ins as governance signals. They tell us something is wrong with our planning or our equipment reliability. Monthly councils focus on bad actors, those chronic problems that consume our time and money. We use cross-functional problem solving here to ensure that the value we're removing is actually being monetized and tracked. Finally, the quarterly review is where executives step in. They shouldn't be bothered with maintenance noise. They should be focused on enterprise-level asset risk and deciding whether to reallocate capital or change operating strategies. A reliability council is not just another committee. Its purpose is decision velocity. It should be lean and empowered. If it can't make decisions and only reviews slides, then it isn't providing governance. Part 5 focuses on data, metrics, and incentives. Governance fails when we're looking at the wrong facts or rewarding the wrong behaviors. Reliability governance requires specific data, from asset criticality and failure history to risk registers and financial translations of downtime. We need to know what a failure costs us in terms of margin and cash. Trust in data is more important than how pretty the dashboard looks. If teams spend meetings debating if a number is correct, they aren't spending time making decisions. Standard definitions and audits are essential governance controls. We must be careful of local optimization. A department can hit all its KPIs while the overall asset system degrades. Governance asks, did the asset system win, rather than did your department win? Effective governance uses a mix of outcome metrics like availability, risk metrics like temporary repair age, and learning metrics like repeat loss reduction. We want to see how the system is improving, not just how it's performing. At the board level, The dashboard should focus on value, risk, behavior, and learning. Trends and long-term consequences are far more important to a director than an isolated monthly percentage. Be warned, metrics can quietly destroy governance. If production targets punish every stop, teams will defer needed care. If cost targets are too rigid, teams will transfer risk into future downtime. Governance must reconcile these conflicts before we blame teams for doing exactly what their KPIs tell them to do. In Part 6, we discuss culture. Governance only becomes a culture when leaders use the system consistently, day in and day out. Leaders set the tone. They should ask for system causes before individual ones, protect time for precision work, and challenge repeat failures more aggressively than one-off events. Recognizing teams for removing losses is key to shifting the culture. Psychological safety is crucial. Operators must feel safe surfacing bad news early without being labeled anti-production. We need to encourage technical dissent because it's often the early warning system for a catastrophic failure. We also need to draw a clear line between accountability and blame. Accountability asks what we can learn. Blame just asks who we can punish. Strong governance actually reduces blame because it makes expectations so much clearer. Ultimately, governance converts ambiguity into discipline. When people see consistent rules for risk and escalation, trust improves. Culture is simply the repeated experience people have with your governance system. Remember, reliability culture isn't found on posters or slogans. It's found in what happens when production pressure hits asset risk. It's found in whether a schedule is actually protected or if engineering is expected to solve recurring defects. In Part 7, we look at the implementation roadmap. Our goal is to build the system properly before we worry about scaling scorecard. In the first 30 days, focus on diagnosis. Map out where decisions currently stall and interview the people on the floor to find where the ownership gaps are. You need to know where the current system is broken before you can fix it. During days 31 to 60, start clarifying governance. Define your RACI, set your risk thresholds, and standardize your definitions. Pick one pilot area to test these rules so you can demonstrate success quickly. By day 100, you should have the operating rhythm launched. Start the reviews, create the executive dashboard, and most importantly, close at least 3 high-value actions to show the system works. Maturity should be evidence-based, not a big bang rollout. Each phase should show measurable changes in how decisions are made and how much value is being protected. This system must be robust enough to survive changes in leadership. The maturity curve moves from reactive, where decisions are event-driven, to value-optimized, where every reliability decision is explicitly tied to enterprise value. Where does your organization sit on this curve today? Before you scale, standardize the essentials: your criticality methodology, your risk acceptance process, and your RCA governance. These are the foundations upon which the rest of the system is built. Finally, in Part 8, we'll look at some case vignettes. These will help us test the governance system in theory before a real-world event tests it for us. Consider this. A critical bearing is showing vibration. Operations wants to keep running for a customer order. Maintenance wants to stop. Who has the right to accept the risk of a catastrophic failure? This is a classic governance question that needs a predefined answer. Or take the case of the permanent, temporary repair. A leak is patched during an upset and then forgotten for 6 months. Without governance visibility, these hidden risks accumulate until they cause a secondary, often more severe, failure. What about repeat failures? If operators reset a machine, maintenance replaces parts, and engineering sees no design flaw, the loss persists because no one is looking at the interaction. A cross-functional council is needed to own the outcome, not just the components. Then there's the capital trap. A site asks for a major replacement because of recurring failures, but a review shows they aren't even doing basic maintenance well. Governance helps the board decide, are we buying a new asset, or are we just compensating for a weak management system? Let's try a board exercise. If a critical utility has multiple defects and a growing backlog, who owns the containment? Who decides the limits? Who calculates the value at risk? If you can't answer these names and roles today, your governance is incomplete. To help you assess your current state, Here are 10 questions every board should ask, ranging from accountability to risk aging and KPI conflicts. These questions will reveal the health of your asset reliability governance. As we wrap up, here's what to stop and what to start. Stop calling reliability a maintenance KPI and stop silent deferrals. Start defining it as an enterprise outcome, assign clear decision rights, and make engineering a core part of defect elimination. My 5 takeaways for you today. Reliability is a leadership outcome. Clear decision rights are its core. The board needs to see risk and value. Governance reduces conflict, and the best system removes losses faster than the business can create them. This presentation was prepared for professional discussion and educational purposes. While the frameworks are based on industrial best practices, they should always be validated against your specific site requirements and standards. The concepts discussed today are aligned with international standards like ISO 55000 and the SMRP body of knowledge. These provide a robust foundation for any organization looking to professionalize their asset management. In closing, remember, reliability is not owned by the department that repairs the equipment. It is owned by the leadership system that decides how assets are operated, cared for, and funded. Govern it clearly, measure it intelligently, and you will turn reliable assets into sustainable business performance. Thank you.